I know why you clicked on this video. Maybe it's because you like to see things getting blown up all the time. It's because you have a destructive mind. Accept this fact. Maybe you'll get to know yourself better. Or, on the other hand, you may have an inquisitive mind and you really want to know what happens to this puny little buck converter when you apply a full load of 3 amps as specified in the datasheet. Well, before we actually apply a load of 3 amps, let's apply a load of say 1.9 or 2 amps with the LED strip for a long time, and let's see what happens, after which we will apply a full load of 3 amps or more, and let's see what happens. So here I have my buck converter soldered onto a PCB with some screw connectors, and here is the positive terminal of the input connected to 2 lead acid batteries in series, which give me 24 volts, and I have stepped it down to 12 volts, which is suitable for the LED strip. Now here is my clamp meter, which I'll just clamp it on, and here we have 1.9 or 2 amps. Now this is the full 5 meter LED strip with 5050 LEDs on board. There we go, somewhere around 1.92 to 2.1 amps. Now let me pull this out and let's see the temperature of the LM2596. Oh, it already started to heat up. It's somewhere around 45 degrees. Now somewhere around 20 to 30 minutes the temperature shoots up to 85 degrees and you need to put on a heat sink. Now in this attempt I'm going to connect a DC motor, which is an inductive load and has a certain inrush current which is greater than the 3 amp mark. I've connected a multimeter in series to constantly monitor the current, and I'm going to jam the shaft of the motor slowly. So here we go, we are coming close to the 3 amps mark and the buck converter is performing pretty well. No problem yet. So let's just try and measure the inrush current. There you go. I've selected the max function on my multimeter, which gives me a max inrush current of 2.970. The same in the second attempt. Oh, sorry, I need to reset it. There you go. Let's try. Oh damn, we are almost near 4 amps. That's 3.936, which is very close to 4 amps, 1 amps greater than the full load current. Now this can be possible because of the inductor and the capacitor on board. Now let's try and jam this shaft, like stall it completely. So I've stalled it and I have a current of 3.9 amps, but still the buck converter is functional. Let's stall it for a long amount of time. Same thing, 3.5, 3.6. Let's stall it more. My god, this thing works. This thing still works. Let's measure the temperature. It's somewhere around 45 to 50 degrees. Well, in another attempt trying the same thing, I got exactly what I wanted to see. White smoke. If you want to see more such videos of testing components or modules at their full potential, let me know what you want to see next in the comment section below. Till then, bye bye.